Okay, so today we're going to do 11.2 on areas of trapezoids, rhombi, and kites. So just real quickly, let's review. A trapezoid is when we have exactly one pair of parallel sides. Okay, the other two can never be parallel. And one moment, these are missing parentheses. So let me put those in there. Okay, so basically we have two formulas that we can use. Some of you prefer a half. I usually use the one, the height, and then base 1 plus base 2 all over 2. You can even do the height over 2 and then base 1 plus base 2. Doesn't matter as long as you're adding the two bases and then doing the multiplying at the end, right? Making sure we're using order of operations. Again, you always need to make sure that the height and the base are always perpendicular to each other. All right, and in this case, the height will actually be perpendicular to both bases. All right, let's find the area. And so I'm going to use the first formula. So I have the height is 12, and then my two bases are 16 and 24. So we're going to add those and then divide that all by 2. So I have, now you could do 12 divided by 2 and make it 6, or you could multiply everything out and then divide. So when I add 16 and 24, I get 40. And so here we can multiply, right? Multiply that out, divide. We should get 240, so that'll be 240. And that will be square yards. Okay, example 2, we want to find the height if we know the area. Okay, so area, A equals, so it's going to be H is what we don't know, base 1 plus base 2. And it doesn't matter which one you make, base 1 and base 2, it's irrelevant. You can put the 35 as base 1, or you can make the 25 as base 1. And we want to divide that all by 2. So 35 plus 25 is 60. So I have 60h over 2, which would just simplify to be 30h. And then if I divide both sides by 30, we get 25. And that'll be 25 meters. Okay, the area of a rhombus and a kite are actually the same. So keep in mind, what is a rhombus? A rhombus is when all the sides are congruent. And then we also know we have the diagonals are perpendicular in a rhombus. The diagonals are perpendicular in a kite. And in a kite, these two sides are congruent and these two. So it's the consecutive sides that are congruent. And the formula we use for this is we're going to multiply the two diagonals together and then divide by 2. Or you can do 1/2 diagonal 1 times diagonal 2. So here we have example 4, finding the area of each rhombus. And this just shows us 18 is diagonal 1 if we want to say, and this is diagonal 2. So the area is going to be 18 times 12 divided by 2. So that's going to be 108. And I don't have any units, so we can just leave it blank. And then for B, all right, I don't know the length of either diagonal, but I see that I have a 62-degree angle and I have the sides are labeled as 13. So I'm thinking of SOHCAHTOA. Okay, so if I focus on just one of these triangles here, and I want to find, let's say, this side, and I want to find this side. So I'll label X and Y, because then we can just double it, and that will give us the length of the diagonals. So let's find X first. In relation to 62 degrees, X is the opposite, 13 is the hypotenuse, so we have to use sine. So we'll have sine of 62 equals X over 13, multiplied by 13 on both sides. So I'm going to substitute I'm going to plug that into my calculator. And I get 11.48 for x. And then for y, now you have a choice. You can either do Pythagorean theorem or you can use cosine because y is the adjacent side. So I could do cosine of 62 equals y over 13. So I'd make sure we go over, press cosine, and I get 6.10 for y. Now, if x is 11.48, then all the way across is going to be double that. So I can say diagonal 1 is going to be 22.96. And then if y is 6.1, we're going to multiply that by 2. So diagonal 2 is 12.2. And now for the formula, kind of running out of room here. Let's go here. So then the area is going to be diagonal 1 times diagonal 2 divided by 2. And we get about 140.06. And again, we don't have units for this one, so we'll just leave it. Okay, last example for this lesson, finding the area of the kite. Again, same formula, diagonal 1 times diagonal 2 divided by 2. I don't know any of the diagonals and I don't know any angles until I look a little more closely. If you look at this triangle, we see that there's a right angle and we see that these two segments are congruent. That makes this a 45, 45, 90 triangle. Now, in this case, I have the hypotenuse is 3 root 2. So in order to find each of those legs, we're going to divide by root 2, which actually works out quite nicely. I end up with 3 here. And then, of course, since these are congruent, this would have to be 3. So I can find the one diagonal, this one going here, is 6. Now I have to find this diagonal. So in order to do that, I'm going to look at this triangle and using, this is no special, so we could use special right triangles if you recognize it's a 30, 60, 90, but that would be difficult for you to recognize. The reason I know it's a 30, 60, 90 is because the hypotenuse is twice the leg. So automatically I know this is going to be 3 root 3. But if you weren't sure about that, then just go ahead, make that x and do Pythagorean theorem. So I'll have x squared plus 3 squared equals 6 squared. So 36 minus 9 is 27. So when I take the square root, you see how we do get 3 root 3. So that makes diagonal 2 3 root 3 plus 3. And I'm going to just plug that into the calculator. We get, that comes out to be 8.20. So now for the area, we have diagonal 1 times diagonal 2 divided by 2. And we get 24.6 square meters. And so for this next homework, you're going to do assignment 30, areas of rhombi, trapezoids, rhombi, and kites. And that worksheet's on MyJag.